This is an intro video on the difference between a molecular and an empirical formula. There are definitely different levels of difficulty when it comes to empirical formula calculations and such, but this is just an intro video on how it works, and we'll have more of those later. So the empirical formula is effectively just the lowest whole number ratio of the elements in a chemical formula, or in a compound. So what we have here is a group of 10 people to help us understand how this works. We have a mix of boys and girls. So B subscript 6, because there are 6 boys in this class, and then we're going to have G subscript 4, because there are 4 girls in the class. This would be an example of the molecular formula, because it tells you exactly how many of each element, so to speak, is in the compound. So we have B6G4. However, if we wanted the empirical formula, what we would do is we would take the molecular formula and convert it by dividing it and getting it all the way down to the lowest whole number ratio. For every 2 girls, there are 3 boys. So it's basically like reducing a fraction. So if you think about this as a fraction of, say, 6 over 4, we would reduce that to 3 over 2. So the empirical formula would be B3G2. So the empirical formula does not tell you exactly how many boys or how many girls are in this total class. You can think of it as the empirical formula does not tell you exactly how many of each element there are in the molecular formula, but it does give you a ratio. It effectively says for every so many of one, there's so many of the other. That's what an empirical formula shows us compared to a molecular formula. Now let's practice. We have H2O, a familiar substance. We have 2 and 1 as our subscripts. We cannot reduce a 2 over 1 ratio anymore because 2 is a prime number and 1 is as low as it can get. So if you have anything that ever has a 1, so we have an invisible 1 here, we have an invisible 1 here, invisible 1 here. Whenever you see an invisible 1 in a formula for the molecular formula, that basically means it automatically has to also be the empirical formula. So H2O can't be reduced anymore. Turns out that for water, the empirical formula is the same as the molecular formula. Now, a similar looking substance, which is hydrogen peroxide, it's deadly, don't drink it, that is going to be a 2 to 2, so the molecular formula is H2O2. If you think about the fact that 2 over 2 could reduce into 1 over 1, or just 1, we are going to get an empirical formula of just HO. We have methane here, 1 and 4, that's going to already be reduced as much as possible, so the empirical formula and the molecular formula match. But then we have a different organic molecule here called benzene. So if you think about that, you could divide both the 6's by 6 because it's a 1-to-1 ratio. Then we're going to get an empirical formula of just CH. So we have C2H4, a different compound. Both are divisible by 2. So C2H4, the empirical formula in terms of the lowest whole number ratio of carbons to hydrogens is just CH2. And then we have another compound that is C2H2. Both are divisible by 2, so you get an empirical formula of just CH. Here's something important though. These compounds are not the same, the molecular compounds, the molecular formulas are not the same, but the empirical formulas are the same. So it's important to note that different molecular formulas can have the same empirical formulas if they still happen to reduce to the same ratio. So this is 6 and 6, which reduces to 1 and 1. And this is 2 and 2, which also reduces to 1 and 1. So these empirical formulas match, even though the molecular formulas don't. Then we have N2O2, which has a similar result as the last one. It's just going to be NO, because if we reduce this ratio of 2 over 2, we get 1 and 1. N2O, though, does not reduce anymore, so we get an empirical formula that matches the molecular formula. And the same is true for NO2. It becomes NO2. Now, NO is already as simple as it can get for this molecule, so the empirical formula is the molecular formula as well. But here we have P4O6. Both 4 and 6 are even numbers, so they're divisible by 2. So we get P2O3. That would be the empirical formula. Here we have a sugar called glucose. 6, 12, and 6 are all divisible by 6. So we would get a ratio of CH2O for glucose, and that would actually be the same ratio as this other sugar called ribose. All of these happen to be divisible by 5, so that would be CH2O as well. So these two empirical formulas are the same. And then we have this compound here. We have a prime number, which is kind of like an alert that we probably aren't going to be able to reduce it. Matter of fact, we have 7, 5, and 3, all of which are prime. None of them evenly go into the other ones. And we have a 6 out here, but that doesn't matter. For this particular compound, which is dynamite or TNT, it actually has an empirical formula that is the same as the molecular formula as well.